So let's go ahead now and we'll go to the cell, new cell, and make sure it's on layout, and this is going to be called NOR. Okay, and make sure you called it NOR, because when we do the layout versus schematic, we want to be able to check both of them, and they have to be the same name in order to do that. So we OK that there. So let's remind ourselves what it is we're trying to build here. If you get into the layers section, Explorer, and head into schematic, we're going to have two NMOS devices, and they're going to be in parallel. So by in parallel, we mean the two sources are joined together and the two drains are joined together. So in effect, you could look at this side here and you could say we're going to go from the source to the drain, to the drain, to the source. So that means that whenever we do the layout for this, we could come in and we can grab the NMOS device. So that's the NMOS there. We'll make it 10. Apply OK, and we'll turn it round, Control J. We'll then get access to it. We'll create an active layer. So we'll go there, double click, and we'll make this 10. Apply OK and Control J. Okay, now we can take these here and we can say Control C, and we'll go Control V, and we've got another two of these here, and then we can head up and get another one of these, Control C and Control V. So let's have a little look and see what we're going to have here. We're going to have the source going through the transistor, and it's going to go to the drain. But the drain of this one is the same as the drain of that one. So that's the drain there. And it's going to go to the source. So it goes source to drain, drain to source. So it means that these are now in parallel. So we can join the active regions together. Left click, right, whoop, undo, undo. Active regions together. We'll go left click, right click, left click, right click, again left and right, and just connect these all the way along. So we can take this one here and we can squeeze it in to this point here, and we can take this one in here and we can squeeze it in to this point here, and we can go ahead and we can squeeze this one in as well. And finally you can get this one and we can squeeze this one into position. Okay, just here, and we'll make it just so they're the same width here. Okay, so that's us created our two parallel NMOS devices. We're going to have a source here, we're going to have a drain, and we're going to have the other source. Now these two sources are going to get connected together and go to ground, and this drain here is going to head up and it's going to go to the output and also up to the PMOS devices. So let's create the two PMOS devices in series. So again, let's have a look at the picture here from the schematic. So from the schematic, we've got two PMOS devices which are in series. So by in series, what we mean is we're going to have this internal connection here is going to be joined together. So in effect, we can look at these and we could say that if this is a PMOS device, then it's going to be holes that are going to be the charge carriers. They're coming from this side to this side. So that'll be the source here, and that will be the drain. And then again, in this one here, we're going to have the source here to the drain. So the source and drain in this instance here are the same point, and we don't need access to it, so we can just have one active region for this point here. So let's go ahead and we'll do that just now. So get into the layout and we'll zoom out a little bit. Now we're going to be grabbing two PMOS devices. So here's a PMOS device here. So there's one, and again we'll make it size 10. OK that, and we'll turn it round, Control J. We'll then get access to it using the P active. We'll make that a size 10 again. and turn it round, Control J. Now we'll take another one of these devices, Control C, Control V, and finally we'll get the output here, Control C and Control V. So that means that we're going to go in effect from the if you like, the drain to this side here, which is the source, which will then be the source and then will be the drain. So let's connect these together. So if we grab this one here, we'll go left click, right click, and we don't need access to this point, so we don't need to put another connection in there. So we just go left click, right click, left click, and right click. And again, we can drag these into position. Oh, let's point there. And I can drag this one in as well. And finally, we can drag this one over. So this is the two PMOS devices now sitting in series. So we can butt these together. That's the wells, the N well and the P well butted together. So again, on this side here with the PMOS devices, we've got, it would be the source to the drain, and yes, again, this would be the drain as well. So source to the drain, to the drain, to the source. Now to get access to this well up here, this is going to be the PMOS, which is going to be sitting in an N well. So we take an N well up here, and let's say we make that a value of 30. And we can position that here. And again, the NMOS device will exist in a P well. So we've got the P well here. We'll double click on this and we'll make that 30. Again, we'll just position that here. So let's have a look again at our schematic. So in our schematic, both of these sources are going to go to ground, and there's one of these here is going to head up to the VDD, and let's say that's the one that's got the A input. So let's just go ahead and we'll put those in. So we head into the layout, then both of these are going to go to ground. So left click, right click, left click, right click. So this is our ground. And in this instance here, we're going to have one of these is going to go up to VDD. So this one here, going to VDD. So we can think about this one here as being our A input. And this one here was going to give us our B input. So let's have a little look at the drawing again, the schematic. We're going to have, in this case here, the output is going to come from the join between these two transistors. So this is the drain, and obviously the drain's got to go up to one of these transistors here as well. So we go to the layout, we're going to have the output is going to come from the drain here. Okay, so this is the drain in this thing here. So I can left click, right click, left click, right click, left click, right click. So this is going to be the output, but the output obviously has still got to go up to the one of these transistors. So it's not that one because that's the final output, so it must be this one here. So I can left click and right click, so that's that connection up to this one. So now let's have a look and we'll see what's going to happen with the gate connections. So if I head into the schematic, you can see that the gate connection for this transistor here goes down to the gate connection for this one. So I could just join these two gates together, and the gate from this one goes down to that one. So if I head into the layout, we can simply join these together, left to right, and I can go left to right, left click, right click. So we've got that connection here. So that's the two gates connected. But we're going to have the input and the output. So we said that this one here could be the A and this one here can be the B. So we need to get those inputs. So head into the layout and we're going to have to get access to this layer here. So how do we get access to that layer? Well, we've got to use this via here. So we connect in here, we go left click, right click, and that's this connection. And again, we can grab this one here and we can grab one of these. We can head over here, and at this level here, we're going to have this one here heading into there. So left click and undo that, edit, undo. I'm going to have this one here into that one there. So I'll move this up a bit. Yep. Delete that. This one here. So we're going to have left click and right click. So this is the two. These are the two inputs. That's the two inputs. That's the output, and that's the VDD, and that's the ground, and that's us built our circuit up. So let's check and see that actually is working. So we can click on this device here, and this is going to be our VDD. So we can go export, create, and we're going to have our VDD. And this one here is going to be our ground. So we can click this one and export, create export, GND. We can click this one here, it's going to be our input. So we can export, create export, and this is going to be our A input. Click this one, and this is going to be our export, which is going to be our B input. And we can click on the output here as well, and we can click on export, and this is going to be our out. So this is our cell now built up. We can get in and check it out and see whether it meets the requirements. We do our DRC. So you can see here we've got a few errors. So let's have a look and see what the errors are. So if we head into Explorer, errors here, and we can start off here with, well, you can see here there's a problem with the distance between these two cells here. So it's not happy with this gap here, and also distance between here and here. So there's an issue here with the metal 1 distances just round about here. So let's get in, we can fix those just now. So we go back in here. What we'll do is we'll take the input here, I'll delete this here, and we'll just leave that here, and we'll take the output from this point here. Also this point here is going to be too close to here, so let's just, I think we can just raise this whole thing up. So that's it raised up here. So let's try tools, DRC, check DRC. Now we're A-OK, everything looks okay. So what we want to do now is we want to get access to the two inputs and the output, but we want to get access not in this layer 1 for the metal. What we're going to do is get the access one layer above. So the bottom layer will be the local connection in between the transistors. The next layer up will be the routing between the blocks or the transistors. So let's say we want to now go from metal 1 up to metal 2. So this is the metal 1 to metal 2 contact, this one here. So we can bring it in here, and we can go left click, right click, and that gives us a metal 1 to metal 2 connection here, and we can shovel it in here. So basically both of those vias, they'll go one above the other. And again here we could grab this one again, pop it over here, we can left click and right click, and we can shift this in. And again we can do the same for this one, we can bring this one in, and we can pop it here, and we can left click, right click, and then we can just move it into position. So let's go and we'll check this out. Tools, DRC, check DRC, everything's A-OK with this. So that looks like it's the end of our design. So let's have a little look at it in the 3D view and we'll see exactly what we've got here. So there's a 3D view here, and you can see here that we've got our connections, local connections here between the transistors in metal 1, and then we've got our outputs here, in the centre, and the input here as well. Input A and input B are heading up onto the metal 2, so we could take this away and this away and this away to some other part of the circuits, and it's not going to interfere with what we have below. So take your time and have a little look at that and see that you understand that design. So what we want to do now is go ahead and simulate this design. So let's go ahead and we'll export the input. So we're going to have this input here. We can go export, create export, and we'll call that our A input. And we're going to have this input here, export, create export. That's going to be our B input, and we'll have our output here. So export, create export, and that's our out. We'll do it in small letters. And before we do anything else, we have to set the spice models for these. So if you click on this instance here, we can get into Tools, and we're going to go to Simulation Spice, the Set Spice model, double click, and it's got, well, Control I, and it's going to be the spice model. So this one's going to be CMOS P. Okay, and this one here, again the spice model for this one is going to be Control I, Control I, cancel. Okay, so we've got to go Tools, Spice Model, and create spice, set spice model. Okay, right, and Control I, and this is CMOS P, apply, okay, and we're going to do it for these two devices as well. So this one's going to be our Tools, set spice model, and this is going to be Control I, and it will be CMOS N, and this one here, finally, Tools, set spice model, and it's going to be Control I, CMOS N. Okay, so that's us set the spice models here. So now we'll go ahead and we'll check for errors as well. So Windows, Tools, DRC, and you can see that there's no errors here. And we can go Tools, and we'll head into the ERC, check wells, and there's no well errors. And finally we can get into the layout versus schematic, which is this NCC. And we can see here comparison with Dural, exports match, topologies match, sizes match. So actually you can see them just in here. So that tells us this is okay. Exports match, topologies match, and sizes match. So that's okay as well. So we're finally ready to simulate it. So let's go ahead and we'll simulate this in its own file. So we go into Cell, New Cell, and make sure it's in Layout, and we'll call it the NOR as capital. NOR underscore, and we'll call it sim. Okay. Now we can go into NOR underscore sim. I'll delete these off. We go into NOR underscore sim, and we can pick out the layout for it. Okay, so this is the layout here, and we'll just drag this in. So this is the layout for NOR underscore sim, and again what we're going to do is we can select it and we can press the little I, and that shows the hierarchy below this point. Now we'll left click here, right click to draw this, left click, right click, and we'll go in and we'll go to the export, create export, and this is our VDD, and this one export, create export, this is our ground. Now we'll also grab these here and we'll take the output from these in metal 2, so we can left click and we'll delete it. We'll need to actually select the metal 2, so that's the metal 2 here, and we'll left click and right click. We'll do the same here. We're going to metal 2 selected, left click, right click, and this one here, left click and right click. And we can also output these here, so click on this one, export, create export, and this was our A, and this is export, create export, this is our out, export, create export, and this is our B. So finally we'll have to grab the spice code from the simulation file here, so we can just go Control C, and we can go into the layout and we can put in there Control V. Okay, that's us ready to do the simulation. So Tools, DRC, Spice, write Spice Deck, and that's us written the Spice Deck there. So then we've got the outputs here, we've got the two inputs and the output. Okay, that, and right click, and again we can add plot plane, add plot pane, and we can grab the A and the B, and you can see we've got the output here. This is the same NOR function, but it's been simulated on the layout. Now just before we leave, there's one other thing that we can do here. Because we started adding in different metal layers, so we've got metal 1 and metal 2, we're going to have parasitic capacitance and resistance and also inductances between the layers and also between the lines. So we can go through an extraction and we can extract those values. So what we could do is, if we head into File, we go to Preferences, and we'll set up the preferences. So if you're in Preferences here, go to Tools and head down to Spice CDL. And I mentioned this in the first video, that we can get in here and we can change this here. This is parasitics. So if you click on conservative RC, so this will run out and work out our resistance and our capacitive parasitics. So if we OK that, apply, OK, and then we just rerun it, Tools, Spice, write Spice Deck. And now you'll see that it's a slightly different now because we've got all of these parasitic values. There's C0, C1, C2, R0, 1, 2. So these are the capacitance and resistive parasitics. So let's see, we'll now look at the output here, VA, VB and Vout. And we'll add plot pane, add plot pane, and we'll grab VA and VB. Now just as a quick look at that, it doesn't look like there's made much change in it, but I haven't looked at it in any detail. But that's how we do the parasitic extraction. So that's all there is for this video. In the next video, we'll take a look at the NAND gate, but I'm not going to go through all the details here. We can use the NAND gate as an exercise for you to work through yourselves to go through a whole design phase. So thank you for listening. I'll get you on the next video. Goodbye.